So let's see today's GFG problem of the day. So what question says that you will be given a matrix and it will contain an integer and you have to find the medium of that. Medium is basically if the array is sorted, then you have to just return its middle element. If the number of element is odd, and in this question the number of element always will be odd because the row and column are always odd. Odd into odd, it will always give odd. So we already know that the number of element is going to be a odd number and we have to just return a middle element. And if it was even, then we have to take average, but it was not in that case, so we have to just return the middle element. So how to solve? One of the brute force approaches like just store all the element in single array, sort it, and just return the middle element, that is n into m by 2. That is what the number of element this matrix has, where n is row and m is column. But we have to come with some optimal approach that should be better than big of n onto m. So let's try to get that. So I have taken the test case given the question and try to come up with the optimal solution. So what I'm saying that if we will convert into an array, means that if we store every element in array and sort it, it will look like this. And if it is sorted, then the medium will be the middle element, this one. So what is speciality of this element? Like the element to its left and right both are equal. Means the element to its left is 4 and the right is also 4. So keeping this in mind, what we can do is time complexity given in question is something of log, so we have to think some kind of binary search. So how we can apply binary search here? One thing in question was given that every row is sorted in the row wise. So what we will try to do, we have to find an element that has the value less than and greater than both are equal. Like all the element to which are less than that, count of that should be equal to the all element that is greater than that. So what we will do that in the question, the number of the element value goes from 0 to 2000. So our answer will definitely lie between this. So we will consider this as a binary range under which the solution will lie. So this is our answer range on which we will apply binary. So this will be our left and this will be right. So what we will do, we will take the mid one, L plus right by 2, and we will try to find what is the, like this will be 0, 1000. We will find what are the element that is less to this L plus r by 2 and number of element that is greater. So if you find the element that are less than is greater and that are the element that are greater is less, so what we will try, we will know that the element to its left is greater and right is less. It means that the element was here, the left one was greater and right one was less. It means we have to move this one because we have to anyhow go in the middle in order to find medium. So we will make our right to mid minus 1. So this is how the binary search will work. And how you will find the count of this? You can find the count of these by going to the every row and find the count not by iterating but using the upper bound lower bound. Was the number you know, and if we use the binary search that is upper bound, you will get an element that is just greater than that, and you can find the what are element are less and greater, and you can go to the every row and just find what are the element that are less and greater. So what will be the time complexity? Time complexity is like one is this search space log of Maxwell, or you can use 0 or 2000, or you can use the maximum value in this matrix and less. So it will be right minus left, and you are applying binary search on each row, that is log of m and log of m times n. So this is what the time complexity which is greater than into n into m.